Hi, good morning to one and all. In previous lecture, we discussed about electrochemical machining process. In this lecture, we discussed about electrochemical grinding process. Here, it is an extension process of electrochemical machining. The principle what we used in electrochemical machining, the same principle we are applying in this electrochemical grinding, but in this process we are using an grinding wheel by using abrasive particles. It is the main difference between between these two processes. Coming to electrochemical grinding process, here it is a combination of ECM and grinding process. Here it is similar to ECM except that the cathode is specially constructed grinding wheel instead of a cathodic shaped. Here the wheel is rotating cathodic tool with abrasive particles on its periphery, that is the surrounding of the wheel is prepared with by using abrasive particles. We prepared one grid. Next, the abrasive material used, that is diamond or aluminum oxide of the grinding wheel, is set in a conductive bonding. Next, the electrolyte flow, usually sodium nitrate, is provided for ECG, that is electrochemical grinding. Next, coming to working principle, here removes material from an electrically conducting workpiece with the help of abrasive wheel bonded with insulating grit is conductive bond material. What is insulating grit? Insulating grit is nothing but whenever the grit is touched with the workpiece, the electricity will not pass, that is one insulation will be provided for non-flowing the electricity from the anode to cathode. Next, observed in this diagram, here we are using power supply, next electrolyte solution, next pump, flow pipes. Through this pipe the electrolyte solution will come in between the tool and workpiece. As in case of electrochemical machining, with the tool is replaced with a grinding wheel, but the remaining process all should be same. Here we are using grinding wheel. Here the 90% of the machining process is complete by using the dissolution process. The 10% by using grinding wheel, it will touch the workpiece, same used in conventional machining process. Here the whenever we switch on the power supply, the electricity will flow to the workpiece, and that is cathode and anode. From the reservoir, the electrolyte solution will pass to the in between tool and workpiece by using the pump. It will flow like this. Here the electrolyte solution will flow in gap between the tool and workpiece. By due to the the electricity will pass, it will be the material of the workpiece should be dissolved, that is the metal removal will takes place. Next, observe here one more diagram. Here the electrolyte solution is coming from the electrolyte reservoir or tank by using pump through the filter to filter the dust particles. It is used to measure the pressure of the electrolyte solution. Next, flow meter is used to control the flow rate, and from these the electrolyte solution will pass in between the tool and workpiece. The workpiece is held by using fixture. After the machining, the electrolyte solution will fall on the bottom tank. Next, whenever we switch on the power supply, the electricity, the positive terminal is connected to the workpiece and negative terminal is connected to the tool by using sleeves. Here the tool will be rotate, that is the grinding wheel. Here we using insulating grid. It is used to insulate, that is the electricity will not pass from the tool to the workpiece during the cutting action or machining. Next, coming to working. In this process, the major material removal takes place by using the electrolytic action, that is 90%. Next, the rest of the metal removal takes place due to the grinding action along with the abrasives used. Next, the mechanical action of the contribute to around 10% due to the abrasive action of the conducting grinding wheel. We are using that is diamonds and aluminum oxides as the abrasive particles. Whenever the workpiece touched with the grinding wheel, the material removes very easily. Next, the pressure applied on the grinding wheel is also much less than the conventional grinding process. In conventional process, we are applying more amount of pressure to remove the material, but in case of this process, we are not using that much of pressure. Next, process parameters: the type of abrasive, grain size, grain concentration, profile of the grinding wheel, and bonding material we used. Next, shape of the work material, pre-treatment process involves and surface topography. Next, machining conditions such as feed rate, wheel speed, depth of cut, all these come under the process parameters, that is governing the metal removal rate. Next, input voltage across the two electrodes. Next, equivalence of atomic weight and valency of elements of work. Next, conductivity of the electrode, gap width. Next, the volumetric removal rate, that is mm cube per minute in ECG, can be calculated by using this relation, that is VRR is equals to epsilon into I by rho into F, where epsilon is equals to equivalent weight in grams. Next, I is equals to machining current. Next, rho is equals to density of workpiece material, gram per mm cube. Next, where F is equals to Faraday's constant. Next, coming to advantages. Here, by using ECG can grind the thin material, that is 1.02 mm, which normally wrapped by the heat and pressure of the conventional grinding. Next, elimination of grinding burrs. As in case of conventional machining, some burrs will be occur at the machining. By using these electrochemical grinding process, we eliminate the burrs. Next, no work hardening. Next, stress free, better surface finish. Next, no cracking. Here the cracking will occur due to the application of more amount of pressure on the material. Next, less frequent wheel dressing. Next, more precise tolerance up to 0.025, that is it is very precise and accuracy by using this process. Next, coming to limitations, that is higher capital cost than conventional machines, process limited to electrically conductive materials. Next, corrosive nature of electrolyte. Next, requires disposal and filtering of electrolyte. Next, more complicated than traditional machining methods. Next, coming to applications. Grinding, it is mainly used to grinding turbine blades, grinding honeycomb metals for aerospace applications. Next, machining carbide tools, machining pots for difficult to cut materials, alloys like inconel, pneumonic, titanium alloys, and metallic composites. Next, honeycomb structures like observed in diagram. Here, these are the honeycomb structures are used in aerospace. It is mainly used to reduce the material and to gain the high strength by using the it is mainly developed based on the honeycomb by using the honeycomb structure. Okay, it is about electrochemical machining process. uh, the In both electrochemical machining and electrochemical gunning mainly works on the same principle, that is Faraday's first law and second law, but the main difference, we are using an abrasive wheel to grind the workpiece. Here the tool will touch the workpiece. uh, During the touching of tool, here the electricity will not pass from tool to workpiece. For that case, we are using an insulation grid around the tool, that is abrasive or abrasive wheel. Okay, thank you.